Good morning students. Once again I welcome you to my video lectures on signals and systems. In the last class we went through the definition of unilateral Z transforms. Now next step is problems on unilateral Z transforms. Determine unilateral Z transform of the following. There are three problems. I have given three problems. I will solve these problems one by one. First one, x of n equal to a power n u of n plus 1. What is u of n plus 1? U of n plus 1 is, I will write it in the form of sequence. U of n plus 1 is 1, 1, 1, 1, 1, 1. It is a shifted function. U of n plus 1, u of n plus 1 is, u of n plus 1 is u of n plus 1 is a shifted step function, to the left, shifted step function to the left. U of n plus 1. So u of n plus 1 is this sequence. So it exists for n equal to minus 1. But for n less than minus 1, it is not going to exist. That is 0, 0, 0, 0, etc. Whereas for n greater than or equal to 0, so its value is 1. This is what is called as u of n plus 1. And you have to find unilateral Z transform for this. Unilateral Z transform. This is the notation. This is the notation I will use. X of n, and here you show Z and write u. It stands for unilateral Z transform. X of n goes to x of z. Now x of z is equal to n equal to 0 to infinity. Now un exists for, u of n plus 1 exists for n equal to minus 1, but we should not take this into consideration in unilateral Z transforms. In the unilateral Z transforms, it is from 0 to infinity. Therefore, from 0 to infinity, a of n and u of n plus 1 is 1, z to the power of minus n. That is n equal to 0 to infinity, n equal to 0 to infinity, a by z to the power of n. Now the Z transform of this is a by z to the power of n, 1 over 1 minus z. 1 over 1 minus z, that is a by z. That is a by z. That is z over z minus a. So this is what is called as unilateral Z transform of a power n u of n plus 1. Now second problem. X of n equal to delta of n plus 1 plus delta of n plus a to the power of n plus 3 u of n plus 1. So what is Z transform? X of n goes to unilateral Z transform given by summation n equal to 0 to infinity delta of n plus 1 plus delta of n plus a power n plus 3 u of n plus 1. Now we know what is delta of n plus 1. Delta of n plus 1 is an impulse function, unit impulse that exists at n equal to minus 1. This value is 1 at n equal to minus 1. At other values of n, its value is 0. Therefore, in unilateral Z transform, we have to consider only for n greater than 0. Therefore, this doesn't come into picture. In unilateral Z transforms. Now, delta of n comes into picture because delta of n is 1 at n equal to 0. Next, a power n plus 3, u of n plus 1. So, like the previous problem, u of n plus 1. So, for u of n plus 1, we have to take only for the values for n greater than 0. Therefore, even in spite of its value at n equal to minus 1, we must not take this into account. Therefore, this reduces to n equal to 0 to infinity delta of n plus a power n plus 3 u of n plus 1. U of n plus 1. Now 0 to infinity delta of n, and here the z transform is z to the power of minus n. Z to the power of minus n. So z to the power of minus n. Now this reduces to n equal to 0 to infinity delta of n z to the power of minus n plus sigma n equal to 0 to infinity a power n plus 3 and u of n plus value is 1 z to the power of minus n equals. Now delta of n exists only at n equal to 0. Therefore, putting n equal to 0 here, z to the power of 0 means 1. Therefore, its value is 1. 1 plus next summation n equal to 0 to infinity a to the power of n plus 3 by z to the power of n, that is 1 plus summation n equal to 0 to infinity then a power split a power n plus 3 as a power n into a power 3 divided by z to the power of n. This is equal to 1 plus summation n equal to 0 to infinity a by z to the power of n plus a plus, not plus, here take a power 3 outside, because a is a constant coefficient, a power 3. Now the z transform is 1 plus a power 3, 1 over 1 minus this one, a by z. Now again and again you need not have to specify the ROC, because for unilateral Z transform it is always exterior of the circle. This is second problem. Now I will solve the third problem. Good morning, students. Now I will continue with the third problem. X of n equal to 1 by 4 to the power of n, u of 3 minus n. So first let us write u of 3 minus 1, and to avoid confusion I will write u of 3 minus 1. Whenever the argument 3 minus n is called argument, as you know that 3 minus n, whatever we write within the parenthesis bracket, that is called as argument. Whenever the argument is positive, that is greater than or equal to 0, for argument greater than or equal to 0, its value is 1. So let us write u of 3 minus n. U of 3 minus n is equal to, so for n equal to 0, u of 3, so argument is positive, its value is 1. Next, n equal to 1, 3 minus 1, 2, argument is positive. Next, n equal to 2, 3 minus 2, 1, argument is positive. Then n equal to 3, 3 minus 3, 0, still argument is positive, its value is 1. But after 3, 4, 5, 6, etc., 3 minus 4, 3 minus 5, 3 minus 6, it becomes negative. Therefore, the argument becomes negative. Therefore, there is no functional value. Therefore, 0, 0, etc., 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 0, 0. Now, for n less than 0, so 3, for example, n equal to minus 1, 3 minus of minus 1, so it is positive. Next, n equal to minus 2, 3 minus minus 2, that is 3 plus 2, 5. So, for n negative, for negative values of n, its value is 1. But while considering the unilateral Z transform, we have to take only from n equal to 0 to infinity. Therefore, x of n going to unilateral Z transform is given by x of z equal to summation n equal to 0 to infinity 1 by 4 to the power of n u of 3 minus n. Then x of z equal to n equal to 0 to infinity, n equal to 0 to infinity 1 by 4 to the power of n, and its value is 1. Its value is 1. But only for these specific values, here n equal to 0, n equal to 1, n equal to 2, n equal to 3. Only for these 4 values of n, its value exists. Its value exists. Therefore, I will write here, I will modify this as n equal to 0 to 3. N equal to 0 to 3. These are the 4 specific values of n for which the functional value is 1. For other values 0. And here there exists a value of 1 for negative values of n. But in unilateral Z transform, we should not take those values. So the lower summation is from 0 to infinity. Therefore, 1 by 4 to the power of n u of 3 minus n, and here you write z to the power of minus n. Z to the power of minus n, x of z equal to summation n equal to 0 to 3, 1 by 4 to the power of n, 1 into z to the power of minus n. Now, there are only 4 terms, n equal to 0, n equal to 1, n equal to 2, n equal to 3. So, I will write individual terms. First, n equal to 0, 1 by 4 to the power of 0 into z to the power of 0 plus 1 by 4 to the power of 1 z to the power of minus 1. Next, plus 1 by 4 to the power of 2, 1 by 4 to the power of 2, 1 by 4 to the power of 2 z to the power of minus 2 plus 1 by 4 to the power of 3 z to the power of minus 3 equals 1 by 4 to the power of 0 is 1, z to the power of 0 is 1 plus 1 by 4 z plus 1 by 16 z square plus 1 by 64 z cube. So with this I have come to the end of the third problem. In the next class I will take up properties. Thank you.